We'll now look at three primitives for synchronizing Pthreads, namely Mutex, and secondly condition variable, which of course are used with a Mutex, and third a barrier. There is also a primitive for performing an operation exactly once, which is used for initialization, and we will come to that as well. The first approach is to avoid synchronization, since if we don't really have to do it, it's better to skip it, since communication synchronization means communication, since we will read and write more data than without synchronization. And this create cache misses and will slow down the program. So if it's possible to divide a program into tasks so that they can be operated on completely in parallel, then that's fine. But usually that's not the case. Okay, so a Mutex. The operations, the functions, the C functions are called always like this, pthread mutex, and then we can initialize it. And what this means is that we have already got the memory for the Mutex, and we pass the address of this Mutex to this function to initialize it. So if we can use a global variable or a local variable or memory from the heap. And then when we initialize it, certain data structures behind the scenes, so to speak, will be created. And when we no longer need the Mutex, we destroy it. So this is not freeing the variable Mutex, but the behind the scenes data structures, resources that are used by the Mutex. Okay, and then we can lock the Mutex, we can use try lock, or we can unlock the Mutex. So if we try to lock a Mutex twice, we will get into problems. So first, this is a local variable, and we initialize it with no special attributes. Lock it, that will work, and then a second lock that will, we will stop there, since this Mutex is already locked, even though it is by ourselves. So to make a recursive Mutex, we have to use this attribute. So we initialize the pthread mutex attribute and then set a certain field of this using, we are not supposed to know how the attributes are organized, but we are allowed to set this. And then we use this attribute when we initialize the Mutex, and now we can lock it twice if we wish. So this is a practical concern. We can either, and this applies to every language of course, we can either protect data or code, and usually it's better to protect the data. It allows more parallelism, but it requires more mutexes. Suppose we have a number of work lists, and then we can protect all of them with one lock. That means protecting the code, or we can protect each individual that means protecting the data. And which one is best depends on the application. By default, assume protecting the data is better. If that would cost too much memory, then you may think of something else. Okay, exactly as the wait set for Java, when we use the wait and notify methods, we have condition variables in Pthreads as well. So if one thread waits for a task to be inserted in a queue, for instance, it can use a condition variable to wait, and then another thread can wake up this waiting thread using signal or broadcast. So these correspond to notify and to notify all.